Hi, everyone. Welcome to the webinar talking about the online Master of Engineering in Computer Engineering at Dartmouth. We're just waiting till everybody gets admitted from the waiting room as we get started here. Welcome. And we're excited to talk to you today about the Master of Engineering at Dartmouth. All right, looks like let's see. Yeah, it looks like we've stopped ticking up. So I will go ahead and get started with the webinar content. Again, welcome. We are here to talk about the online Master of Engineering in Computer Engineering at Dartmouth. I'll start off with some panelist introductions, give a history of Dartmouth and Thayer, talk about a little bit about the program, and then we have a really cool hardware demo. We'll talk about the hardware that we're doing in this program. We'll talk about the student services you get, financial aid, the application process, and then there's time for Q&A. You can put your questions in the chat at any point in the Q&A function. Use the Q&A function for that. You can do that at any point during the webinar. We'll try to get to them either via text while things are going on, or at the end, we'll answer some of them live, and we'll try to do a summary of that. So with that said, let's meet our panelists. So hi, I am Zofia Gatos. I'm the Director of Online Education here at Thayer, and I will pass it off to each of our panelists as they are listed on here to go ahead and introduce themselves. Jason, you're up.
Okay, so greetings. My name is Jason Dahlstrom. Jason, please. I'm one of the faculty for the Online Masters of Engineering program here. I work from the hardware side and really down in the weeds in the hardware. Computer architecture is one of my main focus areas, and I teach in this program the Embedded Systems course 462.
Hi, I'm Ben. I'm the senior content developer for the program. I work between all 9 of the courses to put together the labs and activities that you're going to be doing. I work closely with hardware as well, and we've got some exciting things to show you.
Hi, everyone. I'm Ken Watson. I'm the Online Education Program Manager. I work with students through the admissions and onboarding cycle, as well as on the student experience side while you're progressing through this degree program towards graduation. So I'll be your partner as you make your way through the degree.
Hello, everyone. My name is Ryan West, and I'll be acting as your enrollment counselor throughout the process. Any and all questions you have, please bring them my way. I'll be glad to help. Questions on the degree itself or the application process.
Great. Thank you, everybody, for introducing yourselves, panelists. And I'll tell you a little bit about Thayer and about our online Master of Engineering in Computer Engineering. So the Thayer School of Engineering at Dartmouth was founded in 1867, and it's one of the first professional schools of engineering in the country. And our degree program in computer engineering is Dartmouth's first fully online program. Our philosophy here at Thayer is to do engineering combined with the liberal arts to produce well-rounded and human-centered engineers. We're really trying to prepare the next generation of leaders to solve these problems through engineering research. And our approach is very hands-on. You can see even in this online program, we are still sending out hardware to our students. So you actually are getting to touch physical items and manipulate those and really work with the hardware just like you would on campus. Our students enjoy really close access to the faculty, and all these faculty are really terrific. They're leading experts in their fields, and you get to learn even in this online degree program, small and close-knit and collaborative teams. For a little bit more about our online Master of Engineering in Computer Engineering, we welcomed our first cohort in March of 2024. So we have 2 intakes per year, one in the spring term and one in the fall term. And note that Dartmouth is on quarters. So we have a spring term, a summer term, a fall term, and a winter term. So the terms are only 10 weeks long, which is a period of time that goes by really quickly when you're in a course. So that might be very different from any courses you've taken in the past. Our focus in this Master of Engineering degree program is on intelligent systems. And these are systems that will allow you to work in fields such as virtual and augmented reality, autonomous robots, self-driving cars, AI virtual assistants, wearable and implantable devices. And we're also trying to give you the skills, not just the technical skills for these fields, but also how to work out in the real world that are going to give your work the greatest effect on society. Our program is designed with flexibility. There are 9 specific courses that you need to take, and you can take 1 or 2 at a time. And as I said before, that's a 10-week term. And if you take it in the full-time load, which is taking 2 courses at once, you can finish in as little as 15 months. Otherwise, if you're taking 1 course at a time, going just straight through, it would be 27 months. Here are some sample course plans. This is what it might look like if you are doing a spring start. And so we'll send out these slides afterwards, but this just gives you a sense of what courses you might be taking and when you might be taking them. Now, with that brief introduction, I am going to turn it over to Ben to talk about the hardware in the program.
Yeah, so one of the things that we're most excited about in the program is the fact that you will get to work hands-on with hardware that we're going to ship to you. So 5 of the 9 classes in the program are hardware-based courses. And when you enroll in the program, we're going to ship you a hardware kit that you'll get to keep. It's just yours once you've enrolled. And it's going to contain some really exciting things in it. So I wanted to show some of the things that we'd be sending to you today. So let's switch over the camera. So one of the early courses that you might take in the program is embedded systems, and that's what Professor Dahlstrom, or Jason, teaches, and he'll talk a little bit more about that. In that course, we're going to work with a microprocessor or microcontroller. This is an ARM series microprocessor. We'll teach you how do you use this device up from first principles and documentation to accomplish larger and more complex tasks. We're going to be using a variety of devices. So this would represent a somewhat high-level device where you'd be writing C code in order to program this device. In other courses in the program, like the FPGA class, we're going to ship you a FPGA and microprocessor-based development board known as Zybo. And this board there's a lot on it. We can do a lot with this. We're going to be learning how to use most of the periphery on this, from things like HDMI ports to audio jacks. We're going to be doing a couple of projects using this board throughout the program. So in the first course, the Advanced FPGA Design class, you're going to learn how to use sort of the programmable logic functions on here to implement audio processing techniques. This would be done in a lower level programming language called VHDL. So you're going to be getting a variety of exposure to different levels of sort of design hierarchy in hardware, from higher level C programs to lower level working with individual registers and bits in languages like VHDL. We'll continue using this board for the machine vision course, where we're going to be integrating a camera into it. And so this would have direct applications for things like autonomous vehicles, where we're going to be implementing neural networks and other machine learning techniques in hardware for doing real-time video streaming. We're really excited about this. We're going to keep working our way up the hierarchy in the distributed computing class. We'll leverage devices like Raspberry Pis that are going to be running like a Linux operating system, and we'll be using these devices to communicate to a swarm of cars that you're going to be using to try to solve a maze as a distributed computing problem. And we keep working our way up to the capstone, where we're going to return to an embedded system or microprocessor that's at a higher level. This is going to be leveraging what's known as an Arduino, which you might be familiar with. And here we're going to be using this device, which is a small microprocessor that has Wi-Fi and Bluetooth built into it. You're going to be learning how to use that to implement machine learning techniques for medical applications, for example. So we're going to be working with a wide variety of hardware in this program. The slide deck that you can view after the presentation is going to have more information on the kinds of hardware we're going to poke around and see some of the cool things that we're going to be able to do with it. But you're going to be learning, the techniques and tools that we would use in industry to implement these things, not just in software, but in hardware as well. And so we're really excited about this. And we think it's one of the things that is really special about this program is the fact that you're going to have this at your house and get to use it. And to that end, we're also going to be sending you tools like the Analog Discovery 3 here, which has a variety of wire leads. You're going to learn how to use things like oscilloscopes, logic analyzers, waveform generators, the kinds of tools that you would use in any practical application in industry where you would need to be implementing these kinds of techniques in hardware. So that's the hardware demo for now. Jason's going to show you a more in-depth look at one of the things that you might be doing in the embedded systems course later in this demo.
Sure, thank you. Looks like my audio is working. All right, so as Ben mentioned, each class, there are 5 of the courses have hardware design and build elements to them. Embedded systems, he kept talking about sort of moving up. So embedded systems is the course that really works from first principles with hardware. And so I'm showing you here, hopefully you can see it, a seemingly innocent pair of blinking LEDs. We have the microcontroller development board here, but we also have some basic electronics that you will do the design work for in order to blink the off-board LED, and we'll review the essentials for computing current, working with voltage and resistors, and the needs for each different LED. And we'll also do some basic work with transistors here. So there's an electronics design element and a review of some of the circuits that you may have seen in an earlier physics or intro to electronics course or experience. But we also cover in the first few weeks the tools for developing and programming the microprocessing core. As Ben mentioned, it's an ARM microprocessor on the microcontroller here, and seeing how we use languages like C and assembly to interact with the physical world. And that really is sort of the essence of embedded systems, is that these are devices that interact through sensors and actuators with the physical world. So there are special techniques that we use and specialty purpose tools that we use to develop that. So this is the first complete design. You'll finish this in the first 3 to 4 weeks of the course, incrementally through individual 1-week labs that build up to this. But as the course progresses, we work with more capable sensors. And in the, get my finger on the right side of the board here, this is a MEMS or micro electrical mechanical sensor. It's actually an accelerometer, and inside of this little chip here is a spring mass that's been fabricated at the micro level and can detect the pull of gravity. So you can use this to inertially sense the orientation of this board. And we'll work with this, wiring this over using digital communications, to work with this sensor here. And we'll also be increasing the speed of our design. So instead of blinking things slowly, we move up into things that operate at higher, into the megahertz speeds in terms of input and output from the system. And then at the very end of the course, we look a little bit at communications. Bluetooth is one of the standards right now. So this is a separate microcontroller, my finger on the right side again, that supports Bluetooth low energy. And so we'll do some programming to enable this to communicate by Bluetooth with a Bluetooth app that runs in our browser. And we'll actually observe and convert and denoise and do interesting things with the signals coming off of this inertial sensor here to send this over Bluetooth to a little utility running in your web browser to display the results. And that's a fairly sophisticated embedded system design end to end that you'll complete over the 10 weeks of engineering 462 embedded systems.
Thank you, Jason and Ben, for that great hardware demo. Now, pass it back on over to Ken to talk more about our student support services and some of the things that you can expect as you're getting ready to apply.
Thanks, Sophia. As we said, I know I just ran through some of those slides quickly. The deck will be shared with you, so there will be some additional information. You'll have the opportunity, I should say, to review some of those slides and see in greater depth some of the additional hardware you'll be working with. We'd like to shift the focus now a little bit from the content that you're covering in your classes to things that you can expect as a Dartmouth student. The first thing I will begin with is the fact that We on the student support side have done quite a bit of work in establishing the fact that this program is just as much a part of the Dartmouth community as all of our residential programs. So despite the fact that you might be studying from anywhere in the world outside of Hanover, New Hampshire, or maybe you're in New Hampshire, but regardless of where you're studying from, you are just as much a Dartmouth student as any student in our residential Master of Engineering program or any of our other graduate programs. And because of that, you have access to a number of resources and opportunities available to our students on campus as well. So some of the examples of these are our Dartmouth and Thayer Computing Services and Support. We partner with Coursera, who offers very robust support as well. But as a Dartmouth student, you have access to both the institute level and the Thayer Engineering School's computing services and support with any issues that may come up as you work through this degree program online. Our Dartmouth library services are also very robust, and Thayer has a dedicated engineering librarian who is available to work with you on identifying additional material you may need as you work through the research that's required in this program, along with anything else that comes up as you progress, particularly once you get to your capstone course. Graduate students are eligible to work with our health and mental wellness telehealth organization that we partner with called You Will. So while you obviously are not on campus, can't access things like the medical center, you do have access to this organization that provides mental health and wellness, which is an important part of a successful graduate career. You can even order a Dartmouth ID card. We'll work with you to make sure that you get understand the process and get the picture submitted, and then we'll pick it up and mail it to you if you'd like. And then I think this last one here is, or the second to last one is one of the most important things I think about coming to a school like Dartmouth. The networking opportunities and access to the Alumni Association, I think are in many cases can be just as important as the content you're learning. The skill sets that you're developing in your courses are, of course, the main focus. But once you have graduated from this degree program, you'll have the opportunity to work and connect with colleagues all over the world in a variety of different fields. And the benefit that brings to you personally and professionally, I think, can never be understated. So our networking and alumni association opportunities, I think, are some of the things that we're very, very proud of. And finally, I know it seems early now as you are just probably beginning to think about applying, or maybe you're finishing up your application, but we would welcome you to attend our investiture and commencement ceremonies once you have finished. Again, being just as much a part of the Dartmouth community as our residential students, you are eligible to put on the cap and gown and walk with our on-campus students in graduation. So we would welcome you to come to campus at any point during your academic career and beyond. But at the very least, we'd like to kind of plant the seed now and invite you to come to campus to celebrate with us and the rest of your fellow graduates once you have completed the degree program. So in addition to all of the resources that I mentioned on the previous slide, I think another very important aspect of our offering is our Thayer Career Services Office. This group of dedicated individuals works with students online and offers a variety of resources, including interview preparation and resume review. They host virtual career fairs and can help you identify whether you're looking for an internship or a leg up in your career or moving to the next step. They can work with you to identify how to do that, how to prepare yourself, and how to make the most of those skill sets that you're learning in class, leveraging that with our incredible networking alumni network, and put yourself in a better position than when you came into the degree program. So there are a few examples of some of the employers and sample positions that students have come through in the last couple years. And it's never too early to begin talking with our Thayer Career Services, and I would encourage you from your first term to reach out to them and find out what they can offer. Another important aspect of this degree program is the fact that it's eligible for financial aid. Again, standard financial aid that many of our residential programs are eligible for. If you're a U.S. citizen or a permanent resident, then oftentimes that is in the form of federal financial aid, so student loans. This degree program is eligible for all of the typical loans that you may have seen taken as an undergrad or in previous graduate programs. And so we'll work with you to ensure that that process runs as smoothly as possible. Many of our students also, if you're employed, take advantage of employer tuition, either reimbursement or tuition remission, in which they pay for you. And so we would encourage you when you begin this program to speak to your employer. Oftentimes they're benefiting just as much from you gaining this knowledge as you are yourself. So in many cases, you can seek tuition assistance from your employer, and so we would encourage you to do that. Our colleagues at Coursera have also done quite a bit of work in developing a pretty robust list of additional external funding opportunities. And so if you haven't had a chance to yet, I would encourage you to check out on the Coursera website, funding your education. And there's a whole section there, including links to databases that can help you identify different scholarships and grants for which this degree program is eligible for as well. And again, as a student support team, we will work with you to help identify those possibilities and provide whatever documentation or support you might need in order to lock those in. And then, as Sophia mentioned earlier in the presentation, part-time in this degree program is one course per term. So as long as you're enrolled in at least one course per term, you are eligible for most forms of financial aid, including the federal loans. So just keep that in mind. There's quite a bit of opportunity out there available, and we'll work with you to identify the one that best fits your needs. Okay, and I'm going to hand it over to our admissions enrollment counselor, Ryan, who's going to talk to you a little bit about the application process.
Thank you, Ken. So as you can see on the screen here, Dartmouth is currently enrolling for spring of 2025. Classes will begin March 31st. The priority deadline is quickly approaching, just a few weeks away at this point. So that'll be on November 15th. And then the regular or final deadline will be December 15th for the spring term. If you notice, for the November 15th priority application deadline, you do get your opportunity for an application fee waiver if you submit it by the 15th. And also you'll get a decision approximately a month sooner. So if you're eager to find out your status and start planning, certainly you can look at that priority deadline. If you do not have time to finish it by then, do not worry. So you've got the final deadline coming up a month later. That'll give you additional time if you're working on getting recommendations in or other steps. So the December 15th deadline will be work equally well. But as you can see below there, if you are looking at fall, you can still work with these deadlines to try to get an early decision for the fall term. So Dartmouth actually will review you for the fall term if you submit your fall application by the November 15th or December 15th deadlines, which is really exciting. If you want to make sure to plan for the future, you can't start in the spring, but you don't want to wait until later on to get a decision. This is a great opportunity to get your application underway now. And then speaking of fall, coming up for the fall application period, what you'll see is beginning May 15th, that will be the priority deadline for classes that start September 15th for the fall term. Same concept there. If you, of course, get it in by the priority deadline, your application fee is waived and you will get a little bit sooner decision. June 15th will be the final deadline from there. So never too early to start thinking about fall if spring is coming a little too quickly for you. The one thing I would like to point out in the application process, Dartmouth does a wonderful job looking at applications and reviewing them holistically. So I know there's often questions I get if somebody's qualified, if they meet certain prerequisites, if they don't have a certain skill set. I welcome those questions. We'll talk about that a little later as well, but do understand every part of your application counts. They do look through every aspect of it. So when you're working on the application, take your time, give good thought and detail to every step Your recommendations, those can be incredibly helpful. So make sure you feel it's somebody who can give good perspective on your skill sets. They'll take the time to provide outside details besides just general information about you. Recommendations can be a big help too. But as I mentioned earlier, we'll talk shortly about how you can reach out in a few different ways if you have additional questions.
All right, thank you. And thank you all of you for putting in so many good questions in the chat. I want to speak to some of them that I've seen. We've answered a lot of them in text form, but I wanted to bring up some of the common themes that we are seeing there. We've got a lot of questions about what's required as prerequisites for the program. So we do expect a background in some kind of coding. Not picky about language, but you will need C for the embedded systems course at a minimum. You will also be using Python in several of the courses, maybe even most of the courses. At least one of the courses will use the language Go. That might be a helpful thing to kind of pick up, but we don't require any specific language background, but know that those are the languages that you will be using in the program. We also, particularly the machine learning and signal processing courses, which are the first two courses that you'll take, will require linear algebra and multivariable calculus. We have a number of resources that we've pulled together resources that you can use to brush up on those. Note that we don't really care if you get those skills through formal coursework, through online courses, through reading a textbook, but we do want you to feel confident that you can actually solve math problems in linear algebra and in multivariable calculus. And then we would also love you to come in with some kind of circuit experience. I know many of our students have never touched hardware before, and the current students in the program, and that was challenging but fun. But I think a lot of them came out of the embedded systems course this summer saying, this is really cool, I want to do more of this. So we were all really excited to see that. No specific requirements on GPA. So we review applications holistically and score them on a rubric. So there's no saying, okay, well, if your GPA was, 2.5, you're automatically out or something like that. And in particular, if you have a lower GPA and it's from like 15 or 20 years ago and you've done really substantive work since then, that's far less important. That's going to weigh much less heavily than if your low GPA is very, very recent and you don't have any demonstration of success in your professional career since then. So it also all depends. We don't want to penalize people for something that they did 20 years ago. So that's one thing. Let's see. Anyone else have any other themes that they wanted to call out? I see this question. I've been working in industry for quite some time. Would it be possible to submit recommendation letters from my employers along with professor recommendations? Absolutely, yes. I would love to read recommendations from people who can speak to your current work rather than recommendations from a professor who taught you in one course 15 years ago and doesn't actually remember who you are. Please submit the recommendations from your current professional context. They're going to give us a lot more information about your success in the program. Let's see. Other questions? Just looking through all of this. There are lots of questions about the cost of the program. So unlike other programs at Dartmouth, this program you pay for on a per course basis. So that can be a helpful way to finance your degree. Instead of paying for like a whole semester or term up front, you're paying for however many courses you're taking at a time. So you don't pay for courses until you sign up for them. And so you're paying only for 1 or 2 courses at a time. It's $4,900 per course. So it's roughly $44,100. Well, it is $44,100 for the whole program. And that includes your hardware, There are no additional fees that you have to pay, so that's an all-in cost. We've budgeted for it so that you're not going to have additional fees. You don't pay any of the other fees that you would have. We expect about 15 to 18 hours per week on coursework. Let's see, what's another? What can I do to improve my chances if I have a low GPA and I recently graduated? Really strong recommendation letters can really help you here. You know, a demonstration of why, you know, or an explanation, if you're able to explain in your personal statement, like this happened and it totally derailed my undergraduate career, but now I'm in a much better position to devote the time to the coursework. So other aspects of your application package can definitely make up for a low GPA. GPA is definitely not the only thing that we are looking at. We really do review these applications holistically and are trying to look for reasons to admit people. We're not looking for reasons to turn you away. We're looking for signals that you're going to be successful in the program, because we want all of you to come and be happy and successful here. We don't want to admit you and then have you be miserable. But we really want you to come and to succeed and to this be a program where you can find a good home. All right. Ken?
Sophia, I think that we have a slide here for folks who may want to get some additional information and speak one-on-one. Ryan, can you tell us about your office hours?
Yes, absolutely. As you can see on the screen, you can register for office hours coming up on November 7th. This will be a time where you can come in and ask questions, particularly about the application process. That's the focus of this. It's not as much, it's not a learning session. Hopefully that's what this webinar is done and giving you good details, and we can have separate conversations, of course. But the office hours are specifically designed to give you very specific, detailed guidance on the application process, a great place to ask questions. And also, with others joining, you may have questions they ask that you haven't thought of. So it's a good way as well to just have additional details provided. But I know a lot of people ask questions about how they can strengthen their application. This is exactly what this time is for. Certainly register. You can register immediately with the scanned item on the screen. And then also, of course, I'm glad to spend separate time with you if you're not able to make that session. I typically will reach out to any of you who look into the program with a link to my calendar. Certainly, we can talk by phone or otherwise. But please take advantage of it. I always feel it's better to ask a question than to wonder or to sell yourself short if you're a little bit nervous about applying. Let's make sure to take that time together.
I see one more question has just come in about using an undergraduate thesis paper as part of your application. It probably doesn't really fit directly into the application, but you could certainly talk about the experience of writing a thesis in your personal statement, potentially even include some snippets of it. We don't necessarily need to read it all. You could send it to us, but we wouldn't necessarily need to read all of it. But certainly talking about the experience of doing an undergraduate thesis would be a valuable part of your application. All right. Oh. So this program is, so we've got one more question that's come in, but unfortunately this is about undergraduate programs. This is for our Master of Engineering degree program, which is not an undergraduate program. And we at Dartmouth do not offer any kind of online undergraduate programming. Well, I want to thank everybody for coming and seeing our cool hardware demos to get a flavor of what you've seen, to what you'll be working with in this degree program. We invite you to sign up for those office hours with Ryan so you can talk more about your application, and we hope to see some of you join our program. Thank you very much, and thank you to the panelists for talking to our prospective students about our program. Thank you, everybody.